So, new little task for us today. It's just the Siemens control panel. It's been measuring granite and slate, and it's not turning on, so we're going to see if we can get it working again. I've already taken the screws out because they're a pain in the backside. So we're hoping to see where the power's going. I've had a quick test of this on site and had a look at it under the multimeter, under the microscope, and there's very little actually wrong with it that I can see. So it runs on 24 volts. I'm going to have to connect 24 volts up to this. Goes through a fuse there, and that fuse is fine. It's quite a powerful fuse. Don't know. So we'll have a look and see if we can get this working. I've just prepped up some wires in advance of doing this, so I'm going to just tin them up and then solder them onto the board. The outer one is the 24 volt positive. It's DC. I have to excuse my shaky hands today. Having a bad day of it today. So I'll just tin both of these up. Unfortunately, I've developed over the last few months a slight nervous disorder that's making me get the shakes due to things that are going on in my life at the moment, which I'd rather not discuss, but let's say the lies will be found out as truths very, very soon, and hopefully this will all end. Right. So now I've tinned both those wires up, get some fresh solder onto the boards here, and I'm going to use the contact pads at the back there. I use the lead based solder. This is 6040 lead tin. And it's old stock, which was actually quite difficult to find, so it's the real stuff, not the crappy stuff that you get these days. There's my positive. Excuse blue for negative because I can't find my black wire. Oh, I'm sick of this shaking. Right, you see my legs shaking during this as well. That's part of the same problem I'm running. It's just anxiety type things, so don't worry about it. Right, so this runs on 24 volts. I have a bench power supply which I will show you at some point, which runs at 24 volts. I'm going to reduce the ampage right down to the next to nothing. And connect up my 24 volts. Positive and negative. Now this control board normally has data coming in here and going out. So I'm just going to turn the power up. It's using 100 milliamps. No, it's using 60 milliamps, 24.7 volts. In the factory it actually gets more than that. So, I'll switch the power supply off for a minute. Pull this out. Put it back in here. Best we can. Connect the screen up and the touchpad. That's the touchpad, that's the screen. See what happens when you power it up. Lights up for just a split second, then goes off. That split second, put it on amps, it takes 200 milliamps and it goes off again. So we need to find out where that power's going, what's happening to it. So let's see if we can trace some of these wires and tracks. Now I've got a nice piece of marble here, which is non-conductive. So we've got a negative rail here, which is on a silk screen all the way across the back here. Goes all the way around. This whole area here is a negative. Goes down to there. I don't know why I haven't just filled that in, because that still goes across to here, so the whole thing's a negative. I could have actually just joined that. Got lots of vias going through the board here. First via goes through there to that capacitor, and that capacitor is connected to there via. Push the soldering iron off because I don't need that for now. Switch my multimeter on. Switch it on to 200 volts DC. That's 20 volts is the next one down. I'll check to see if there's power coming in at that cap, which there isn't, and that cap, which there isn't. Check that the power's on there. Have to turn the power supply on, doesn't it? Yeah, I've got 24.4 volts there. In theory I should have 24 volts across that capacitor. Just like that. But I don't. So, turn it over. Check on that via and that via. Nope. 24 volts going to there. 22 volts going to there. 22 volts. 23 volts. Okay, they're not shunts. Nothing on that one. I think we need to find out what these are, because that one's not got anything going through it. There's absolutely nothing coming through there. There's 0.9 volts. 0.9 volts. Diodes. 0.8 volts on it. That's a long way around longer. There, 0.8 volts. So let's connect to the chassis earth. I'll use a different lead. Just dropping all my tools on the floor, don't worry about me, that's normal. Right. Climb onto the earth, much better. So I've got 1.2 volts there and 1.2 volts there. 0 volts there and 22 volts there. So the power is not coming through that, whatever that is. There's also nothing at all coming through this. 1.1 volts. 1 volt, 0.1 volt. 0.8 volts, 0.8 volts. There's no power on there, okay. No power on there. No power on any of the chips. Okay, I need to do a little bit of research into these two plates here. It looks like they are not fuses. That's what I assumed they were. It also looks like the power does not go through that via on that board. It only goes through the top. It goes straight to there. So there's no power getting through this. Okay, I'm going to do a quick test of that on a shelf. I'll switch the power off. Test to see whether or not these are meant to be shorted. Well, that one certainly is a short, and that one says it's a short. No 0.01, 0.05, right. I wonder if they are meant to be some sort of fuse. Let's have a look under the microscope quickly and have a look and see what this is. A part number written on it. It's written in such tiny little letters. It's etched into the top. So come on. Oh yeah, there it is. Zoom out a bit. (050) BUO. Right, I'm going to go and have a quick look and see what this is. Okay, after a little bit of investigation, that was a fuse. It is a auto-tripping fuse. Quite interesting. What we're going to have to do is, there's a component somewhere in the power supply that is shorting to earth, and whenever you increase the ampage, that goes through this, or the voltage, and set 24 volts to it, it's shorting it out and tripping the fuse. So both of these are fuses. So what I'm going to have to do is basically bypass the fuse and put power through the board at a lower ampage and a lower voltage, put something on that will show temperature, e.g. our liquid alcohol, and that alcohol will show which component's getting hot, and in theory that component should be able to be removed, and hopefully that will solve the problem and we'll be able to find another component to replace it. So first jobs first, bypass the fuse. It's quite difficult considering it's not a through-hole fuse. No. So I'm going to have to put something in its place temporarily. A tiny little bit of wire, I think. Actually, what I could do might be a better idea. That is on the positive line. So I'll take the positive line off and I'll solder it to that capacitor there, that one there, and that will give me the 24 volts past the fuse. So I'll bypass the fuse basically. I'll have to wait for the solder line to heat up a bit. 200, 300. Takes a while for the heat to get from here down here. It's the only problem with these old school style soldering irons, where there's a ceramic heater, and the ceramic heater only actually comes down to here. It takes quite a while. So desolder the positive. Off we go. Look at all that. Solder that onto, I'm going to have to flow some new solder onto here. Come on. Yes, I just use my trousers to clean the end of the soldering iron. Just get that onto there. Not the best thermal conductor, this soldering iron is really designed for very, very minute soldering. I haven't been able to find out where my other ones are. Right, that bypasses the fuse. So, soldering iron back up there. Apologies for the arm in the way. Turn the soldering iron off. Now what I'm going to do, let's just hold that out of the way, switch the power supply on and increase the current. A little bit of alcohol on the board. Just slowly increase the current and see which component gets hot. And I'll try this side as well, just in case there's anything else over there. Now I've got half an amp going through there, so one of those components should, in theory, start to get hot. And there it is. So that component there is getting hot. It's a bit hard to see with my cap on. A quick look. A bit more alcohol on. Just to check it is definitely that component that's drying out first, and not one next to it. Yes it is. Right, so let's remove that component, find out what it is. Turn the power off. Let's dry the board out a bit. It's got lots of alcohol on it now. Warm it up a bit because it will obviously be cooled after all the alcohol. Maybe a bit more than that. Come on. So full blast air and 400 odd degrees Celsius. Tweezers. Which ones do I use today? Use those ones. A little bit of flux. Oh, I hate this flux. It's so sticky. It's a horrible flux to use. Right, let's back up the temperature. On the board just so I can see the one component. There we go. I've got to remember what orientation this is on because I haven't got a schematic for this. So I'll try not to drop it or fling it anywhere. Over here. Quick look at it under the microscope if I can. And that's PJ048EXP. So let's have a quick look for that. Let's just check this diode as well while we're at it. Put the multimeter into diode mode. I'm afraid you can't see any of my multimeters or anything like that because they're all bench ones. So we've got a direct short that way around. I've just said I have to remember which way this goes. So it goes with the negative on that side. I think I might actually mark the board up for that. Oh. Right, we're sort of getting a direct short both directions. So yes, that diode looks like it's shorted out in both directions. So, let's check the next diode along. This on, and this is the one on the board. So 1700, which is what you expect, and a short Oh, these probes are horrible. Pretty much a short that direction. Yeah, right, so that diode's working fine. Okay, I will get back to you as soon as I find out what the value of this diode is and see whether or not I can replace it with a standard component. Back in a sec. Okay, can't find that component. I have plugged this back in. That diode appears to be just a regulating diode for the 24 volts that comes in. It doesn't do anything other than stop the reverse voltage. So I know that this machine actually had a power surge and blew the large trip switches that are inside the machine. So we'll try powering it on, supply it with 24 volts, very very small amperage, and see what happens. And that's it, up and running. Now this basically measures automatically the position of the blade for cutting this granite stuff and marble. So it's a bit like a CNC machine for marble, but yeah, it's all up and running again. And yeah. Oh, I've changed the language. Never mind. Right. Should be all up and running now. Hopefully the language won't have changed and stay changed. We'll see. Shouldn't remember it. Okay, yep, so keypad's working. Info settings, contrast, device info, version number, log on settings, etc, etc, etc. So yeah, all the buttons are working. We can call that a win for now, and I shall see if I can find one of these diodes. If it needs it in the future, I'll install it. But for now, it's up and running, it's working. I'll go back to the customer for now and see how we get on. Bye bye. And that's everything disconnected. I forgot to say, this crazy little board that just measures things, that's all it does. The customer wanted a replacement, cost, because it's important for measuring all of the granite without having to use a measuring tape, etc. It gets things more accurate. It's £500 for this board. It's failed because of around about a 3. Well, actually, it's 30 pence for about 100 of these components. So 0.3 of a penny component failing. So yeah, it's sometimes worthwhile just quickly pulling things apart and checking them and finding the short to earth. Anyway, that's all for now. Next job is a unfortunate machine that's been to another repair shop, which is going to be great fun. And that is this lovely Abermac, which is going to be good fun because half the screws are missing, and I'm not going to say which shop it is, but they've stuck their sticker on, and it is a 1286, no screen, absolutely nothing on the screen, just goes funny colours. Been told it was a graphic card, but that's my next job. That alongside the other Abermac that I still haven't finished just because of time constraints. So I'm going to screw the screws back in this, take it down, and install it back in this massive big lathe machine thing, and earn a little bit more money. Have fun.